Are roots and x-intercepts the same thing in algebra? Imagine you're walking along a roller coaster track and suddenly the ride touches the ground. That point where it hits the ground is like the x-intercept of a graph. Now, think about solving an equation where the function equals 0. Those solutions are called roots. Are these two ideas connected? Let's find out. In algebra, roots are the values of that make the function equal to 0. For example, if you have the equation squared minus 4 equals 0, solving it gives u equals to and x equals -2. These are the roots because they satisfy the equation. Now, x-intercepts are the points on a graph where the curve crosses or touches the x-axis. When you plot the same equation, the points where the graph hits the x-axis are at 2, 0, and -2, 0. These points are called x-intercepts. So, roots and x-intercepts are closely related but from different angles. Roots are the solutions you find algebraically, just the x-values where the function equals 0. X-intercepts are the actual points on the graph where the function crosses the x-axis. For many functions, especially polynomials like quadratics, these two ideas match perfectly. The roots give you the x-values, and those same x-values tell you where the graph touches or crosses the x-axis. However, not all roots show up as x-intercepts. Sometimes, roots can be complex numbers, which are not visible on the graph because the graph exists only in the real coordinate plane. For example, if a quadratic has no real solutions, it does not cross the x-axis at all, meaning no x-intercepts. Also, in rational functions, roots are found by setting the numerator to 0, but if those roots make the denominator 0, they don't appear as x-intercepts. They create holes or discontinuities instead. The behavior of the graph at an x-intercept depends on the root's multiplicity. If a root has an even multiplicity, like squared or quartic roots, the graph touches the x-axis and bounces back. If the multiplicity is odd, the graph crosses the x-axis at that point. This helps us understand how the graph behaves near those roots. When solving quadratic equations, finding the roots involves setting the quadratic equal to 0, and solving for x, these roots directly correspond to the x-intercepts of the parabola. Recognizing this link makes it easier to picture how algebraic solutions relate to the graph. In summary, roots are the solutions to the equation where the function equals 0, and x-intercepts are the points where the graph crosses the x-axis. For many functions, especially polynomials, they are the same. Understanding this connection helps you see how algebra and graphing work together to give a complete picture of a function.